On the morning of February 15th, 2013, the sky over a Russian city turned brighter than the sun, and not one person on Earth knew it was coming. For a few seconds, a second sun hung over Chelyabinsk, white, silent, trailing a column of smoke higher than any building ever made. People stopped their cars in the road. They walked to their windows. They lifted their phones to film the strange light in the sky. And then, almost 90 seconds later, the sound caught up. A shockwave rolled across the city with enough force to blow in the glass of around 7,000 buildings at once, to knock people off their feet, to injure roughly 1,500 of them in a single breath. The rock that did this was about 20 meters across, smaller than a house. By the standards of the things that cross Earth's path, it was a pebble, and we never saw it coming. The Chelyabinsk rock came at us out of the one direction no telescope on Earth can watch. It came from the daytime sky, riding inward along the glare of the sun. Every camera we point at the dark to hunt for asteroids was blind to it, because it was hiding inside the light. We did not catch it a year before, or a week before, or even an hour before. We learned its name from dashcam footage. Put yourself there. If you had been in Chelyabinsk that morning, the light would have reached you first, in total silence. You would have done what everyone did. You would have walked to the window to see what it was, and the glass you were standing at, 90 seconds later, is exactly what the shockwave came for. This is the rule the sky always follows. The light reaches us first, the violence comes a step behind, and we are always a step behind the violence. And the unsettling part is how ordinary this is. Earth is hit by something every single day. Most of it burns up unseen, high overhead, a streak of light that no one is awake to watch. But every few decades, the sky sends down something big enough to remind us of a fact we work very hard to forget. The Chelyabinsk rock was the smallest warning the sky has ever handed us. The ground under your feet is not a fortress. It is a target. That same morning, astronomers were already watching a different asteroid. Its name was 2012 DA14. A Spanish observatory had found it a year earlier. They had been tracking it ever since, plotting its path, and they knew exactly where it was going. They knew it would miss. They were right. 16 hours after the Chelyabinsk rock fell, 2012 DA14 slid past Earth at a distance of 27,700 kilometers. That is closer than the ring of satellites we use for weather, television, and the GPS in your phone. Astronomers tracked it across the sky with their telescopes. It was about 45 meters across, more than twice the size of the rock that had hit the city. The bigger rock, the tracked rock, the one we were watching, it missed us. The smaller rock, The untracked rock, the one coming out of the sun, it hit a city. This was not bad luck. This is the rule. We can only see what we look at, and we cannot look at the sun. The same week, in Vienna, a United Nations committee was sitting in a conference room, debating whether the asteroid threat was worth taking seriously at all. The technical subcommittee of the Committee on the Peaceful Uses of Outer Space was in session. The agenda item was the asteroid hazard. They were still in the room when the news from Russia broke. Imagine the silence. Scientists from a dozen nations sitting around a long table debating a hypothetical while 1,600 kilometers of atmosphere and a city of 1 million people answered the question for them. Within a year, the International Asteroid Warning Network was standing, the first shared early warning line for the whole planet. A formal channel, finally, for the one thing the Chelyabinsk morning had proven we still could not do. See what is coming. For almost all of human history, the light reached us first, and we could only flinch. Then, on September 26, 2022, our species did something it had never done. NASA flew a spacecraft the size of a vending machine, called DART, straight into a small asteroid named Dimorphos, on purpose, at more than 22,000 kilometers per hour. The impact shifted the asteroid's orbit by about 32 minutes, the first time in 4 billion years that anything living on this planet moved a celestial body on purpose. A rock the size of a vending machine against a rock the size of a stadium, and the smaller one won. But moving a rock is not what the movies taught you to expect. You do not fly up and blow it apart. A shattered asteroid is not a solved problem. It is a shotgun blast of smaller rocks arriving at the same place at the same time. The real method is quieter. You strike the rock years, ideally decades, before it reaches us, and you change its speed by only a few millimeters per second. That whisper of a nudge, multiplied across hundreds of millions of kilometers of orbit, is enough to turn a direct hit into a clean miss. But look hard at the requirement. Decades of warning. To move a rock in time, you first have to see it coming in time. And seeing it is the one thing we are still bad at. In December 2024, a telescope in Chile caught a rock now called 2024 YR4. Within weeks, its odds of striking Earth in 2032 climbed to 3.1%, the highest ever recorded for an asteroid its size. More observations pulled the threat back to almost nothing. We got lucky. The math saved us. But that rock was found only because it was sitting in the dark where we could see it. The ones that come in from the glare of the sun, the way Chelyabinsk did, we still cannot see at all. And one is already on the calendar. On April 13th, 2029, a Friday, an asteroid called Apophis, around 370 meters across, will pass so close to Earth that it will slide beneath the highest satellites we have. Close enough to watch with your naked eye, as a star drifting against the dark, visible to perhaps 2 billion people. It will miss. This time, we are almost certain it will miss. So go outside on the next clear night and look up at all that calm and distance and quiet dark. It looks empty. It looks safe. It is neither. The same sky that gave Chelyabinsk a second sun for a few seconds is full of slow, silent, moving rock, most of which we have never seen, on paths we have not yet drawn. It warns us, the only way it ever has, with light, long before the sound. The dinosaurs never looked up. We only just started to listen, and we still cannot see the part of the sky the sun is hiding.